Hey, kitty. Hello. Kitty. Hello. So random cat just came with me upstairs and we slept together last night. Hello! I've already done photosynthesis. In fact, photosynthesis was the first topic ever in the summer outside with the chocolate and the potato, and weird things happened. But I haven't done the limiting factors of photosynthesis, which is pretty much a big part of photosynthesis. Now, obviously, there's loads of things that affect photosynthesis. You know, pretty much anything you can think of is probably in some weird way going to affect photosynthesis. You know, the flapping butterfly in Taiwan is going to affect the photosynthesis of a plant. Yeah, that's not the point. The point is there are 3 factors that you are supposed to know about. 3 factors that are the top factors. And those 3 factors are temperature, carbon dioxide concentration, and light. Now, let's take them step by step. Right, temperature is measured in degrees Celsius, Kelvin, Fahrenheit. Who uses Fahrenheit anyway? CO2 concentration is measured in pressure, or, well, I suppose it depends. You can measure it in many different things. I mean, on the website here it says carbon dioxide concentration is measured in pressure or volume. So, you know, there's multiple things that growers can use to measure CO2 concentration or any other gas concentration. And light has got its own units called lux, L-U-X, and 100,000 of those are available in light to a photosynthesizing plant. And we're going to look at why these 3 things are important as limiting factors in photosynthesis. But I think the biggest takeaway from this topic is that no one factor can ever be enough for photosynthesis. No one factor trumps them all to make a plant photosynthesize continuously and increasingly. They all need to come together and they all depend on one another, and the cumulative effect of them is how much a plant can photosynthesize. The first factor is temperature. What has temperature got to do with photosynthesis? Why temperature? What? You know, temperature is so broad and generic, and there's nothing special about photosynthesis in itself. Photosynthesis does not have a special relationship with temperature. Temperature generally is a massive thing that affects everything. Any reaction in an organism, on a rock, in the clouds, you know, it's just generally a big thing. And it is linked to the fact that photosynthesize uses up a bunch of different enzymes. And enzymes are very temperature sensitive. If you go to the enzyme topic, the whole thing about enzymes, one of the big things, is that they are so sensitive to pH, to temperature, and what happens is that if the temperature is too high, if you shine a strong light that emits a lot of heat onto a plant before it even burns its leaves off, the enzymes are going to denature. Their 3-dimensional structure is going to be it's going to be changed so that it doesn't function anymore. Now, if the temperature is too low, if it drops too low, then they're not going to be denatured, but their activity is going to slow down. Now, you might wonder, why does the activity slow down when you drop the temperature? Why do enzymes slow down as the temperature decreases? Well, I'm sorry, I mean, who do you think you are? I mean, are you not slowed down in winter? Are you gonna say you're not? Isn't science enlightening? Moving right along. CO2 concentration is the second limiting factor, and CO2 concentration does have a very tight and special relationship with photosynthesis, unlike temperature. Why? Well, CO2 is one of the starting ingredients for photosynthesis. Photosynthesis makes glucose. Glucose has carbon atoms. Where does it get carbon atoms? Water, H2O, there's no carbon in there. Oxygen, O2, there's no carbon in there. Random poop has carbon, but that's not the point. The point is CO2 concentration is important because CO2 is where the carbon resides that is going to undergo these reactions and then be literally put into glucose rather than its initial CO2. It's like trying to make cake and having some sugar for it, you know. You're not going to be able to make more cake than the sugar allows. So the CO2 concentration determines how much glucose you can make because you need that CO2. It's as simple as that. Simple. Plain. Everything all roll into one. Finally, light intensity. Light. You might think light sounds like temperature, it's just this generic thing. No. I mean, yeah, light is great and, you know, life relies on light and light is wonderful, but it does have a special relation with photosynthesis because it provides the energy, a special kind of energy, light energy, heat energy, chemical energy, mysterious energy, dark energy, deep energy. This is light energy, and photosynthesis needs this particular kind of energy, light energy, to trigger photosynthesis, the light-dependent reaction of photosynthesis, the first part of photosynthesis that splits the water. There's more details on that in the light-dependent reaction bit of this. And of course, just like all the other ones, if you increase light, photosynthesis rate goes up and up and up, and then it just stops increasing, it just plateaus, it just stops. Same with CO2, same with temperature, same with everything, because, as I said, individually, they contribute to the increase. But if you just increase one and not the others are going to be slowing it down. You're making the cake, you have 1 kilo of sugar, you have 10 kilos of flour, and you're just like, okay, 11 kilos of flour, 12 kilos of flour, and you're like, why can't I make more cakes? 15 kilos of flour, 20 million kilos of flour! You have no sugar! There is no sugar! That's it, and I am sure that this was far more enjoyable for me than it is for you. Now, mid-month is approaching again, and the, I think, third outrage of the month is due, so if you have any ideas, let me know, and I'll see if I can do them, because outrage of the month is the favorite part of the month, so I